Today, I want to explore an interesting tool to be used with the TradingView strategy tester, and that is a Monte Carlo simulation feature. First, what the hell is Monte Carlo simulation? I hear some of you ask. The concept of Monte Carlo simulation originated in the mid 20th century, primarily developed by scientists working on the Manhattan Project. The Manhattan Project was a jazz fusion album. Oh, I am just kidding. I was actually, but it was also the project that developed the atomic bomb. The concept of Monte Carlo simulation was developed by two mathematicians working on the Manhattan Project named John von Neumann and Stanis Lamb. We will just call him Jane and Stan. Stan was contemplating a way to solve complex problems in neutron diffusion and other areas that were difficult to handle with traditional analytical methods. Yes, I am getting this from the chat GTP. Believe it or not, I don't typically study neutron diffusion in my spare time. So he suggested using random sampling and statistical analysis to approximate solutions to these problems. Basically, Monte Carlo simulations are useful when we need more data than we have available to adequately test a theory. The name Monte Carlo was coined by one of the Stan's colleagues, Nicholas Metropolis, and it's named after the Monte Carlo Casino in Monaco. The Monte Carlo Casino is quite famous for a few statistical concepts such as gambler's fallacy, also known as the Monte Carlo fallacy. I don't know what Monte Carlo specifically did to warrant this reputation is the birthplace for all these statistical analysis terms, but it is a great marketing. Anyway, the name Monte Carlo simulation was chosen because the method involves random sampling and probabilistic analysis, which is similar to the randomness inherent in gambling games. And I guess because Monaco and Monte Carlo is pretty badass. It is an amazing place. So why not name things after it? But what does all this have to do with trading well? Let me show you. What you see on my screen right now is a visual representation of what a Monte Carlo simulation looks like. So here we have 100 sample Monte Carlo run on our trading strategy. This is just a hypothetical example, and what you see is the best and worst 5 Monte Carlo simulations from a backtest. So, when we are back testing a system, we typically work with a single run backtest. That means we run our system, we run our conditions, our entries, our exist over a single set of data, which is the historical price action that we run our test on, and that gives us an end action of how our system performed in the past on price action that has already unfolded now. That information is extremely valuable, but it is also potentially misleading because the future will never unfold exactly as the past did. And that is why we see all those disclaimers that past performance is not indicative of future performance in all the trading disclaimers. That is true. The past is not indicative of what will happen in the future. Sure, the future may be similar to the past, and it probably will be similar, but it won't always be exactly the same. And that is why where a tool is like Monte Carlo simulation comes into the backtesting process. The idea is instead of running a backtest over a single set of data, you randomize that data slightly. So the four sort of basic core pillars of Monte Carlo backtest run are: first, keeping trades, so you randomly do not take trades that you otherwise should have just to introduce a bit more randomness into a system. This is particularly useful for systems like trend following systems, which depend on really big size gains to make up for its losses. If you have a system that has like a 30 or 40% win rate, but it hits the occasional 10 to 1 winner, that might still be a profitable system. But there is a lot of luck involved in a system like that as well, because if you have a single run backtest where you hit a couple of 10 to 1 winners, that salvage your system, and had you missed a few of those, the system would have been completely unprofitable over that period of time. Then that is a very dangerous system to trade potentially. And by randomly skipping trades, we can see how silent our system is to slight variations to future price. Second, randomness, a second method for Monte Carlo simulating. This can be stacked on top of each other. By the way, although you don't want to stack too many goods, it gets a bit too much. But a second option for Monte Carlo simulation is randomizing the trade sequence. So that means instead of taking trade 1 trade, 2 trade, 3, maybe you take trade 3 first, and then trade 1 and then trade 2 with the TradingView strategy tester. We can't do that sort of thing. Unfortunately, the strategy tester is quite basic in its functionality, so that is out of the question for us. We can randomly skip trades, and that is what I am going to show you guys how to do today. And one of the third option is increasing the variance of the data we are working with. So that might mean things like third, randomizing the open, high, low and close slightly, so that the bars we are trading are slightly different to what they were historically. Again, we can't do that in PineScript unfortunately, but we can randomize our entry and exit price, and even our entry price if we use limit orders. But for today's video, I want to keep things simple. We are going to stick to random trade skipping and random entry exit variants, also known as spread. We can actually simulate spread in our system using very simple code that works much better than the inbuilt tools. We have to work with the strategy tester. So with all that said, let us get into some code. So here on my chart I have an example script. I literally just opened up the Pine editor and created a new strategy using the default conditions for a TradingView example template script, and I have tweaked it slightly so that we are working with a fixed take profit and stop losses instead of reversing our position when there is a moving average crossover. And again, this is not a strategy we are working with here. This is just a feature and a tool that you can implement into your existing strategies or systems you are working on. So the system is not going to be profitable, but that is not the point. The point is the techniques we are learning and implementing here. So you can see these yellow labels on my chart. These represent trades that were skipped due to Monte Carlo simulation. And if I zoom out, we have a lot of skip trades here. That is because I have set my skip rate to 60%, which is too high. You would not set it this high normally. I just did this to demonstrate what this feature is doing. So if we zoom in, this here should have been a long trade, but we did not take any trade. We skipped that trade because of the random Monte Carlo simulation, and something you might not have noticed. But if I zoom in to on a trade, Let us start with this short trade here. If you look closely, you will notice that our stop loss for this trade is here and we take profit is here. But we did not exit at our take profit. We exited slightly higher, about 1 pip higher from this green line. If I had to guess, if we measure this out, oh yeah, zero point 0.8 pip early. We exited early, which means that is going to affect our risk reward profile, and this happens in real trading. Right now, I am on a forex market, but this applies to most markets that are tradable. We have the issue of spread, and spread is random mostly unless you are using a broker like Trade Nation, which uses fixed spreads, which is quite voluntarily as far as I know. You are the only broker that do that, especially on TradingView. That is not a broker recommendation. I am not affiliated with them, but it is worth checking out if you are having issues with spread, because knowing you are spread ahead of time in a superpower in especially in forex trading. But most of us don't have fixed spreads and we are affected by the random spread, which means late when we place a trade like this long trade. Here we have our stop loss set and we have our take profit set, and when price gets close to our take profit, sometimes it will feel a little bit early because of the spread, and we have our take profit set, and when price gets close to our take profit, sometimes it will feel a little bit early because of the spread, and instead of a 2 is to 1 risk reward, we end up with like a 1.9 or something like that. That adds up over time combined with the commission cost, commission drag. You can quickly see a system go from profitable on paper when you are not accounting for commission and you are not accounting for slippage to completely worthless and untradable once those factors are introduced in real trading. So, Monte Carlo simulation of the spread and trade skipping can help us determine how robust our trading system is, and I will show you a real life example of this on a different script at the end of the video. But for now, let us get into the code. So it is really simple to add this to your scripts. Just import public open source Gen library. All you need to do is type in import Gen control space and find Gen library. Current version is 8. So I import that 8 version of my library as Gen, the keyword Gen, and that gives me access to all of these functions. I won't go over all of this today. We are just going to focus on skip trade Monte Carlo and one of the random number features in that library. So then I have a few user inputs. I have a skip percentage and our random spread, and then this little checkbox here does nothing, just simply turning this on or off. We will randomize my chart because every time you change a setting in the script, it re-executes on price action, and because we are randomizing these values, they will be randomly changed every time we change a value. So turning this box on or off, if you look closely, is randomizing my chart. So that is the only purpose of this little checkbox. Doesn't actually do anything in the script. So first of all, let us have a look at the skip trade code. So what I have here is two trade conditions, long trades and short trades. These are just simple moving average crossovers. So I am just checking, do we have a crossover and do we not have an open position. If our position size is 0, that means we are flat. That means our long conditions are met and we are able to take a trade. But before we enter our trade, I am checking this library function here. Skip trade Monte Carlo. If not, skip trade Monte Carlo. So if this function returns false, we do enter our trade. And if I hover over this, it will explain what this does. This checks to see if trade should be skipped to emulate rudimentary Monte Carlo simulation. It returns true. If the trade is skipped, false. If it is not skipped and it takes two parameters, the percentage chance to skip a trade and a debug value. So skip trade chance is our user input. It is set to 10 by default, 10%, which is still pretty high, but I will leave it there for now. And debug is set to true. That paints these little yellow labels. If I set that to false, we don't get any labels on the chart. So we won't know when a trade is skipped. It is probably recommended to leave that on, so you know what your script is doing, but you can turn it off by just not specifying that value or that parameter. And that is it. That is literally it. That is all you need to do in order to introduce trade skipping into your system is just add this check. But you can turn it off by just not specifying that value or that parameter. And that is it. That is literally it. That is all you need to do in order to introduce trade skipping into your system is just add this check here before you enter your trades. You can add this directly to the long condition. So I could add that in here and remove this check. The problem with this approach is that this long condition is checked on every single bar on my chart, and so what we will get here is these yellow labels plotting on pretty much every bar on my chart. Right now it is set to 60. If I set this to let me set it to 100 right now just to show you what I mean. This label will appear on every single bar as you see here, because my long condition check is being checked on every single bar. If you only want the debug labels to display when an actual trade is skipped, you need to nest this check after your long condition or short condition check. So what happens here is this is run on every single bar. If it is true, then this is a run, and so this will display the label only on trading setups that were actually skipped, and bars that do not meet our trading setups are completely ignored. And that is it. That is it for the Monte Carlo trade skipping. Very simple. All you need to do is add a user input to set the percentage chance and add this check to your entries. That is all the spread check. On the other hand is a little bit more complicated. So here is the randomized spread. It is set to 1 pip by default. For this I have to use my random function here. Now you don't need to understand what a pseudo random number generator is for our purposes. It is fine. This will do the job just fine. It will simulate a random number between this value and this value. So between 0 and this number, Monte Carlo spread value will be somewhere between 0 and 1. We convert that into pips using my gen.toPips function for forex. This is necessary for some other markets. You might not need to use this function, but because I am on a forex market right now, I need to convert this value into pips because we are working with whole numbers. Here I could get rid of this completely and set my random spread to what is a pip on euro dollar, like 0.00001 or whatever, but I like to work with whole numbers, so I am going to use this conversion function here. Now I am going to skip over the rest of the code for calculating our stop loss. take profit, etc. because it is not relevant for the lesson. You should be replacing all of this code with your own system code. Anyway, I just want to show you guys how to randomize the spread when it comes to existing our trades with profit targets and stop losses. So let us skip ahead to that part of the script. Once we have set our take profit and stop loss, we can come down here to where we calculate our randomized spread in a realistic manner, which is to say harming our trade outcome. So we don't want our Monte Carlo simulation to extend our take profit and reduce our stop loss. Maybe you do want to reduce your stop loss because sometimes your stop loss will be hit early and your take profit will also be hit early. In fact, that is the most likely thing to happen. So we could adjust our code here to emulate that. So we have a random spread stop loss and take profit value here. And then if we are in a long trade, we randomize that spread accordingly to harm the trade. And if we are in a short trade, we have to do it little differently. So let us have a look at a long trade first. For a long trade, our stop loss is being filled beyond our actual desired stop loss. We should probably bump this up so that it gets hit early. That is more likely to happen with spread. We all know that especially on lower time frames, you set up your trade and then price comes close to it and you get topped out and then price reverses and goes on to be a would-be winner. It did not touch your stop loss, but you still got stopped out because of the spread. That is a common occurrence in forex trading, and that is what this sort of code can help you detect way before you start experiencing that in real markets. And it can give you a warning sign that your system is not resilient enough to deal with the spread. That is the whole point of this, to give you more realistic backtesting simulations and give you an idea of whether or not what you plan to trade will actually work in real markets. So for the stop loss, I can get rid of that because our Monte Carlo spread is always a positive number. So the stop loss number being a positive number will add to this. So now if I save my code, keep an eye on this trade, assuming it doesn't get skipped by the Monte Carlo, then our stop loss would randomize in the opposite direction. Now there we go, and in fact on this particular trade the spread barely came into effect with like a fraction of pip above our stop loss. So that is pretty accurate to cause. You are not always going to be stopped out early on your stop loss due to spread, but it is likely to happen and sometimes it will exceed your stop loss. So maybe in these cases you want to completely randomize the spread. In that case, just set this number to instead of 0, set it to random spread multiplied by 1 and with the default value of 1, that will randomize the spread between minus 1 pip and positive 1 pip. And then if you do that, you don't need to have this code here at all. You can just add the random Montreal spread onto your take profit and stop loss. But anyway, before we wrap up this video, let us fix our short trade. Let us find a short trade. Here we go, this one got stopped out. You can see our fill price was beyond our stop loss. So what I need to do is flip this value to -1 for our stop loss on a short trade, and that will bring this below our stop loss. There we go. So now we are being stopped out early, and that is it. That is really it. That is all. There is a randomizing your limit orders. Now the reason I went to the trouble of this code and did not just simply add the spread directly to our take profit. When we calculate our stops and targets is so that we can usually see the randomization in effect. So this is where our stop loss should have been. But this is where we get filled, and in order to have both values, we need to be able to draw our original take profit and stop loss but apply the random spread to our exit code. We will leave this course code to this video in the pinned comment below. If nothing else, you should definitely play around with the trade skipping code. That is the easiest code to implement, especially if your system is not using fixed targets. That is the best way to introduce some randomness into your backtest. And as I said, I just added this little checkbox here. If you bring up the strategy tester and I bump up my position size, I don't know why the strategy tester starts with $1 million balance. That is not realistic in the slightest. Let us start with a 10,000 and using a standard lot. Now the system is nowhere near profitable, but let us have a look at impact of randomizing trade skipping. So remember, we have got a 2:1 risk reward profile. We are skipping 10% of trades and we are randomizing our spread by 1 pip, and I am only just noticing now that this checkbox is actually just flipping between the same value. So there is no randomness occurring here, which is quite interesting. I am not sure why that is. I guess the strategy tester is just reverting to a CED copy of the strategy performance. So what I will do is change this to an integer and see if this helps. So let us bring out the strategy tester. That is definitely change our values. So let us change this and see what happens. Okay, now we are getting a more randomized result. So the checkbox was not working. I need to increment this value, which is quite interesting. This actually I did not expect that this actually saves the backtest run. So if you look here, we got 76.26. If I go up to 1, we have 14.33. If I go back to 0, we have 76.26. So this is a handy way to cycle through Monte Carlo runs. Now this system is random. The entry conditions are terrible. They are very simplistic. They are very basic for a proper system. A robust system that you have actually put some proper work into developing a 10%. Trade skip rate should not affect your result nearly as much as this. And if it does, then that is a sign that perhaps your system is not as robust as it should be, and it requires further investigation, further strengthening in terms of its resilience towards future changes in price action conditions and markets of evolving over time. Markets act differently as they did in the past. A good system will be resilient towards that, a robust towards that, and future changes in price. Behavior won't affect the system dramatically. Eventually, sure, the system will probably break the lower the time frame, the quicker. That is all. See you again.